Those answers would work just wonderful. Okay. Change colors for number 3 here. Number 3, I got 1 minus the absolute value of A divided by B. Oh, hello. Let's put a parenthesis there. Something goes in that. So plugging in for A, I'm going to plug in negative 2/3. And plugging in for B, I'm going to put in a 2. All right, remember these are absolute values, so I'm going to make them a little bigger, a little taller, a little straighter, darker, so I know what's going on. They're not ones. All right, so I got to do inside the absolute value first, negative 2/3. There's nothing really to do in there, but now I need to get rid of the absolute value. It's like a parenthesis, so we're going to do it on the P level of PEMDAS. So I got negative 1 minus, and when you get rid of the absolute value symbols, you make it positive because it's the distance from 0, and distance can't be negative. So we're just going to change that to a positive 2/3 divided by 2. Now, what do we do next? Should we go ahead and take the 1 and subtract the 2/3 and then divide by 2? Well, PEMDAS says parentheses, exponent, multiply, divide, add, subtract. So the divide's got to come before the subtraction. So the 1 minus is going to stay. But we have to do this divide fraction. Okay, so let's check it out up here. 2 divided by 2/3 divided by 2. Well, with fraction we should never actually divide. Okay, we stay with 2/3. We change the sign to multiply, and we flip the other one over, take the reciprocal. Well, it's not a fraction, so if I change it into a fraction, 2/1, when I flip it over, it becomes 1/2. Now that I like because there's a 2 on top and a 2 on bottom that reduce to 1. 1 times 1 is 1 on top. 3 times 1 is 3 on bottom, 1/3. So 1 minus 1/3. Well, if you take 1, you divide it into 3 things, okay, 3 pieces, you'll have 3 pieces. Okay. If you divide it into 3, you'll have 3. So I have 3/3 minus 1/3. 3 things minus 1 things is 2 out of 3 things. 2/3. Those fractions are kind of tough. Those are a place a review skill or an online video or an app that gets you tested in those skills might be a good thing. Let's look at number 4 for the last. 5 times the s minus the square root of the r divided by 6. For r, I'm putting in 9. S, I'm putting in 1.5. So, parentheses first. The square root symbol acts like a parentheses. If there's stuff underneath it, it acts like an exponent if it's just a number or something that we can square root easily. So let's do the square root first because it's like an exponent because we can't do anything with the 9. So the 5 times the 5 times 1.5 minus 3, square root of 9 is 3, divided by 6. 5 times 1.5, well, 1.5. 5 times 5 is 25. 5, 6, 7 in one decimal place. 7.5 minus 3 divided by 6. 3 divided by 6. Well, as a fraction division, I see that 3 goes into both. 3 goes into 3 once. 3 goes into 6 twice. Becomes 1/2. 1/2 is the same thing as 0.5. 7.5 minus the 0.5. So you take the 0.5 away, leaves you with just 7. Okay, those are some complex pieces. They're putting in lots of little pieces of math. But we should be coming into the algebra, excuse me, ready to be able to do that kind of math. Knowing how to square root, knowing order of operations, knowing how to multiply, divide, add, subtract. So those shouldn't be too bad for us. If there are, give them a go again. You can rewind a bit and watch over how I do that and what I do at which time, making sure the PEMDAS is being followed. Now let's move on. Solving a real-life problem. When the math book says real-life problem, what they mean is we're doing a word problem. Okay, and this is as close to a real-life situation that you might have to use this kind of math. So, you want to tile a 10-foot square floor with tiles that are twice as long as they are wide. Determine how many tiles you need to cover the floor when the tile length is 2 feet. All right, we got all kinds of information in there. Let's take it a piece of a sentence at a time. You want to tile a 10-foot square floor. When in doubt with a word problem, draw a picture of it. So we know the floor is square. And since we know this floor is square, we know something's very special about it. All the sides are the same length. So if it's a 10-foot square floor, this side's 10, that side's 10, that side's 10, that side's 10. That's what we know so far. And we want to cover the surface with tiles. The surface is area. So we're looking for area. And if you remember, area equals length times width. So our area here is 10 times 10, or 100 feet squared. That's the area we're trying to cover. We're going to cover it with a tile. The tile itself is going to have an area. And however much of that area gets covered, we're going to have to multiply it times however many we need to get to that 100. So let's talk about the tile. This was the floor. Let's talk about the tile. A tile needs to be twice as long as it is wide. So these sides are the same, and those sides are the same. Even though my sides don't look very straight. There we go, it's a little better. Okay, we know that it is twice as long as it is wide. So if it is x wide, that means it is 2x long. If it's x wide, then it's 2x long. Right? And as we say, it says determine how many tiles you need to cover the floor when the tile length is 2 feet. Well, the long, right, is 2x. This is equal to 2. So that means that this side is 2. But what is the other side? What's the x side? Well, if 2x equals 2, to find out what x is, you get rid of the other stuff, get x by itself, divide by 2. X is 1. This is a 1. So we know the area of this to be 2 times 1, which is 2. So if the area of the tile is 2 square feet, and we need to get it to 100 square feet, 2 square feet times how many square feet, how many tiles, is going to equal 100 square feet. Okay, well that's 2 times... Let's see, we don't want to use x this time. I'm going to use t for tile. 2 times the number of tiles equals 100. Divide by the 2. The number of the tiles is 50. If we had 50 tiles, 2 feet by 1 feet, we could cover the 100 square foot floor, or the 10 foot square floor, all completely. So we needed a lot of stuff in that one. We needed the area of the floor. We had to know about a square and a square floor. Squares have same sides all the way around. We had to know the formula for area, length times width. Then we had to figure it for the tile, because once we know how much surface the tile has, we can figure out how many surfaces do we need to add to the total of the floor. I had to do a lot of work to get the one answer. And that's kind of how the real life problems tend to go. They're usually not that cut and dry. They usually have do this in order to find that. So always make sure you highlight or you underline the part you're supposed to find. And make sure your answer, you circle, goes back and answers what it is. Determine how many tiles. We need 50 tiles. We answered the question. Okay, go ahead and give number 5 a try. It's using the similar problem, but they changed one piece of it. So it's going to be a similar setup. They changed just one piece. They changed the length of the foot. So determine how many tiles. Again, we're looking for tiles. And the length has changed to 1/2 foot. So give it a pause. Give it a try. Okay. Our floor, still 10 by 10. Area 100 feet squared. Our tiles changed though. Okay. If it's the length is 2 times the width, and if our length is now 1/2, okay, what is our width? Well, 2x equals 1/2 divided by 2. Okay, so x equals 1/2 divided by 2. Now I wrote it this way because making a big complex fraction where you have 1/2 on top of the fraction gets kind of weird. So I did it this way because of stay, change, flip it over. 1 times 1 is 1, 2 times 2 is 4, so this side's 1/4. So now the length and the width of the tile have changed. We've got area equals length times width. Area equals 1/2 was the length and the width was 1/4. Go straight across the top. Area equals 1 times 8. So the area is 1/8 of a foot. So how many eighth of a foot do you need to make 100 feet? So how many 1/8 tiles do we need to make 100 perfectly? Well, divide by 1/8. Divide by 1/8. So that's supposed to be 1/8, not half. So that's stay, change, flip. So 100, change, flip it over. 100 times 8 is 800 tiles. Need 800 tiles if they are only 1/8 of a foot in square feet. That makes sense. They're really small, so we need a whole lot of them. That's how we work on that one. Those are standard operations. Add, subtract, multiply, divide, square root, parentheses. Those are the things we're used to seeing. There is something called non-standard operations. The mathematical operations you've learned so far, such as the standard operations of addition and subtraction, give you instructions for what you do with two numbers. For instance, addition, denoted by the plus symbol, instructs you to find the sum of two numbers. You know the plus sign means put them together. You know the line by itself, the minus symbol or the subtraction symbol, means to take them apart. See what the difference is. Take away. You can also define non-standard operations using combinations of standard operations. Basically, you can make up a symbol that means this math expression, so you don't have to keep writing the math expression over and over again. So you could say A, box with a dot in it, B, is going to be equal to 4A over B. If you define that as that's what that is, if you say, okay, now do 2 box dot of 4, this was A, this was B. So all you have to do is substitute like we did with when they told us A equals 2 and B equals 4. Now they're just telling us, well, if A box dot of B is this equation, plug in 2 and plug in 4. So that means take 4 times something over something. We got an A on top. A is 2. It's the first thing. We got a B on bottom. It's a 4. 4 times 2 is 8 over 4. 4 goes into 8 2 times. Ooh, weird. So let's look at the expression examples that they give us for non-standard operations. In the instructions, evaluate the expression using non-standard operations.